Today I'm going to explain hemostasis. Hemostasis simply means stopping bleeding after a blood vessel has been injured. The easiest way to understand it is to think of your body trying to repair a leak in a pipe. There are 4 main steps to hemostasis. The first step is squeezing the vessel. The second step is plugging the hole. The third step is strengthening the plug. And the fourth step is removing the clot when the repair is finished. Let's expound on that first step, which is squeezing the vessel. First, the injured blood vessel constricts and gets smaller. The smooth muscle in the vessel wall contracts, which reduces the amount of blood flowing through the injured area. It's like pinching a leaking hose. You're not fixing the hole yet, but you're slowing down the amount of fluid that's escaping. Now let's look at step 2, which is plugging the hole. This is actually primary hemostasis, where the platelets form a temporary plug. When the blood vessel is damaged, the area underneath the vessel lining becomes exposed. Von Willebrand factor, or VWF, helps platelets stick to that damaged area. And once the platelets stick, they become activated. They change shape and release chemicals such as ADP and thromboxane A2, which basically sends out a message saying, we have an injury over here, bring more platelets. So essentially, more platelets arrive and stick together. This is called platelet aggregation, and together they form a platelet plug. So think of it this way. The platelets stick, they activate, and then they clump. Now let's look at that third step, which is strengthening the plug. Yeah, so the platelet plug helps to stop the bleeding, but it's still relatively weak. So now we need secondary hemostasis, which strengthens the plug with fibrin. And this happens through coagulation cascade. There are 2 pathways, the intrinsic and the extrinsic pathway, but the important thing to know is that they eventually actually come together. So during this step, prothrombin is an inactive protein circulating in the blood. During the coagulation cascade, the intrinsic and extrinsic pathways ultimately form prothrombin activator, which converts prothrombin into thrombin, which is an active enzyme. And it's the thrombin that actually converts fibrinogen into fibrin. And it's the fibrin that forms a strong mesh or net around the platelet plug. So think of the platelets as putting a temporary patch over the hole, and the fibrin is putting cement around the patch to make it stronger. Then there's also factor 13 that helps cross-link the fibrin fibers to make the clot even more stable. The final step is tightening and removing the clot. Once the bleeding has stopped, the clot begins to retract or tighten. The platelets actually contract and pull on the fibrin fibers, helping pull the damaged edges of the vessel closer together. But once the vessel has healed, we don't need that clot anymore. And this is where fibrinolysis comes in. TBA helps convert plasminogen into plasmin. Plasmin then breaks down the fibrin mesh, which helps dissolve the clot. So the easiest way to remember hemostasis is that it squeezes, it plugs, it strengthens, and then it removes. The blood vessels squeeze to slow bleeding, platelets plug the injury, fibrin strengthens the platelet plug, and once healing occurs, the body removes the clot. Together, blood vessels, platelets, clotting factors, and endothelium work as a coordinated repair system to stop blood loss after an injury.